All right, welcome back. This subunit is going to be on air quality, and we're going to talk a little bit about renewable use resources and pollution. So the objectives of this subunit are going to be to identify various causes of air pollution, explain the impact of air pollution on the environment, assess the methods that can be utilized to improve air quality, and propose alternative methods of improving air quality. So what are some causes of air pollution? We've got human sources, and we've got some other sources down here, but mostly our human sources relate to burning fuels. So we've got stationary sources. That's going to be fuel burning or heating devices. So some examples of that are going to be incinerators, smokestacks, furnaces, anything that stays in one place and emits air pollution. We've got mobile sources. A good example of that is going to be vehicles, but also aircraft and marine vessels, etc. There's all sorts of mobile sources of air pollution that humans cause. Also controlled burns. So agriculture and forestry management, we have controlled burns, and when you burn wood, it releases carbon dioxide into the atmosphere. And as I said before in two subunits ago, the deforestation industry is 20% of the global carbon dioxide emissions. So that's a crazy amount. We also have chemicals that we pollute the air with, dust, landfill waste, which is methane gas. This is going to be kind of a quiz question. So landfill waste is methane gas. Decomposing landfill waste creates methane. Fumes from solvents like hairspray, paint, aerosols. A lot of people don't understand, but these solvents are really, really bad for the air quality. They do a lot for creating the greenhouse gas effect. And we talked about that in the climate change unit as well. One funny thing is that our president once sprayed a bunch of aerosols inside of like a meeting and was like, I don't see it going anywhere. So, some people really don't understand how this works. But when you spray it, that aerosol propellant goes into the atmosphere and creates that greenhouse gas effect. It's really bad. And then our military also creates air pollution. So nuclear weapons, that's going to be a big one. It's not just our military, it's militaries all over the world. Every time you test a nuclear weapon, that stuff is going into the atmosphere. Toxic gases and rocketry. Every time you shoot a rocket up into the atmosphere, that's going to release a lot of pollutants. So here are some smokestacks. You can see they're just, you can see the pollution going into the air. A lot of this is steam, but right in here you see how it's all gray? That's smog. So we've got another good example here, transportation, bunch of smog. Someone burning a fire. Right there is a whole bunch of air pollutant. And then here, you're going to want to probably pause the PowerPoint here and just take a look at all of this stuff. So, vehicles, exhaust, towns and homes, factories, agriculture, wildfires, volcanoes, airplanes, all that stuff are primary pollutants. Then they mix with other things in the atmosphere and they create secondary pollutants, which a lot of the times these are worse. So just take a look at that, be kind of aware. And then here's just a really good example of how bad aerosols are. You see this like skull and crossbones there, just spraying up the earth with it. Then here's rocketry. Look at all that right there. That's all air pollutant. And it's going to continue to happen until this rocket explodes. So we've got some natural sources as well. Dust is a big one. That's technically an aerosol, so that will lead to either cooling or warming, depending on what it combines with. Volcanic activity is a huge one. You get chlorine, sulfur, ash is the biggest one there. Methane emission, so natural sources of methane emission are just going to be like farts. So cow farts, human farts. Every time someone digests and releases that gas, that's methane gas. Radon gas is a big one. And radon is just the radioactive decay of radium in the Earth's crust. And that generally comes from uranium as well. So uranium decays into radium, and radium decays, letting loose this radon gas. So a lot of people, especially in Colorado, have to have radon systems that release radon outside of their home because it's poisonous and you can die from it. And then wildfires. Wildfires are natural and human impacted. So wildfires release smoke and CO2 in the atmosphere. Generally, that's not such a great thing. Here's just a little graph of how uranium kind of turns into radium, and radium releases radon gas, which comes up and seeps into your house through the crust. Here's a nice little picture of a volcano. What's interesting about this is we've got this huge city right across the bay from this volcano. They are going to immediately see the impacts of air pollution. So they're going to have to be walking around with like masks on for the next couple weeks. And then this is going to also get into the atmosphere, and it's going to move, and it'll go from country to country until eventually, usually precipitation interacts with this ash, and then it falls down to the ground. Here's a wildfire. Again, you can see the juxtaposition of this smoke right near a really heavily populated area. So they're going to be feeling the effects of that air pollution significantly right away, but it's also going to travel and go to other places. So let's talk about some impacts of air pollution. A big one we talked about previously is acid rain. So acid rain is going to lower the pH of the soil. It's going to decrease biodiversity because that soil is going to become infertile. So there's going to be only a few select species that are able to live in that area. And that's acid rain is generally when CO2 interacts with water in the atmosphere. It creates carbonic acid, and then it falls down. And that's going to continue to happen with increases in CO2 emissions. Another thing is smog. So smog is a big deal right now. Not only does it reduce sunlight for photosynthesis, but it also creates a lot of respiratory illnesses. So 2/3 or 2/6 of the deaths in the world today are due to pollution, and 2/3 of those 2/6 deaths are due to air pollution. So that's something to think about. That's mainly smog there. Another thing that happens is ocean acidification. That's going to be kind of the same thing as acid rain, but on a larger scale. CO2 emissions are going to interact with the water. They're going to lower the pH of the oceans. A lot of things are going to happen. We talked about coral bleaching. Essentially, just ecosystems are going to die. And we get a lot of stuff from the ocean, so we have to make sure that we try and keep that thing preserved. And then the last big one is greenhouse gases. And we all should know what's going on there because we all did the climate change unit, right? Okay, so how do we reduce air pollution? Well, we've got a couple things. The Clean Air Act is a really good one. It was a law enacted by Congress, and it just defines the EPA's responsibilities. And the EPA is the Environmental Protection Agency. Lately, it's been kind of defunded a little bit. It's losing a lot of its control. That's just what happens with politics when you get a new administration in. They like to change things up a little bit, but I can guarantee you in the next couple years this thing will be up and running again, and we will be caring about the environment again. So don't worry, the world is not going to explode because of our new administration. But the EPA's responsibilities were defined to protect and improve the national air quality and the ozone layer. So the EPA has like pretty broad responsibilities with air quality because, you know, if you're trying to protect and improve the national air quality, like it's everywhere. So they have a really broad responsibility there. So we also have things called control devices, which just are particulate control devices. So they just take like dust and ash from the atmosphere and kind of clean up the air. So we've got mechanical collectors, and a good example of that is a cyclonic separation machine. I'll show you pictures of all these as well. Electrostatic precipitators and dust collectors. Dust collectors are just going to be like filters. So you'll see those in vacuums. They're everywhere. Like your lint screen is a dust collector in your dryer. And then we have scrubbers. And people don't really understand what scrubbers are or how they work, so I will go into that a little bit for you as well. And then we also have land use planning. So a really good example of land use planning and urban development is like in Colorado Springs here, we have a coal plant right in the middle of downtown. And they just recently put a sulfur dioxide scrubber into this coal plant like 2 years ago. And so that's probably a little bit too late. And fun fact, that coal plant is the only coal plant west of the Mississippi that is located in a downtown region still. So we kind of need to move that thing. So here we've got a cyclonic separator. We get air coming in through here, air with particulate, and we have it kind of circle around in this little separator. The particulate's gonna kind of like be forced down through this little hole, and then clean air is gonna come out through the top. Right here is the electrostatic precipitator. So we get this incoming particles, like gas filled with particles. It's going to hit these little charged ionic like pieces of metal essentially. And these pieces of metal, they're charged in such a way that they attract particulates. So when they flow through here, the particulates get stuck on this metal part and clean air is able to go through. And some of you may have this at home. What it does is it like electrically like disintegrates those particulates too. So you'll hear it going like zap, 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 like all the time. We have one in my home. And then here's a filter, you know, before, after. This is all the dust and gross stuff. And this is a scrubber. So this is what they use in coal plants to clean up the air, basically. So the contaminated gas goes in here. It goes through a packed bed, which this is just like a lot of sediment or things that are really good at filtering out particulates. And then a scrubbing liquid is pushed down through that bed. So that soaks up all the particulates and it pushes it down into this liquid reservoir and it pushes it out through this little teeny hole and they're able to clean it from there. So then the air comes up through one last little like mist eliminator. It's just getting rid of the precipitation and clean air comes out of there. So these are like relatively simple and cheap in terms of like millions of dollars, but people kind of refuse to use them. So here's something that they use in China. This is like a filtration unit, and it's been proven to reduce smog emissions in the areas that they are, like really dramatically. And the cool thing about this is that there's zero emissions. So they take the smog and they create jewelry out of it. And so people can come up and pay for little blocks of smog in jewelry. So imagine your loved one giving you an engagement ring made from smog. So let's talk about alternative energy, and then that'll be it. We've got renewables, which you should all know what renewables are. They reduce toxic byproducts, aka air pollutants, and they preserve natural resources. They're super awesome. And they're really economically friendly. Like, this is the way that the world needs to start going. We've got wind power, which is the conversion of wind energy into a usable form. But the only problem is that wind is really unpredictable. So you can't really rely on wind power all too much. You just have to use it as another source. Or if you have a place where you know wind is always constantly going to be going, like on a cliffside, those are good places. We have solar power, which converts sunlight into electricity. They're only productive during sunlight hours and only in regions with sunlight exposure, though, so that's their drawback. We have geothermal power, which is heat stored in the earth is converted into energy. Usually it's like they put water down there and create steam to turn a generator, that sort of thing. But they're only available in certain regions. Like some areas don't have geothermal energy underneath of them. There's no like volcanic activity going on underneath of there. So that's its drawback. And then, the thing about geothermal power is that it's not weather related. So that's going to be a quiz question. This has nothing to do with weather. It just has to do with like magma under the ground. And then we have wave and water energy. So we've been using wave and water energy for a long time. So it uses wave power or the current to turn a generator and produce electricity. Its drawback is to use it on a large like mass scale, it uses a lot of water. So that's its drawback right there. So that is everything for this unit. If you have any questions, comments, or concerns, go ahead and let me know. Otherwise, have a wonderful week.